A very good morning to Encik Suhaimi bin Simon. So my name is Lowicat, metric number AE 220058. So we are from Group 2. So today we are going to present our project. Okay. So these our team members. Okay. Next. Okay. In part A, we have already correct all the data and information from our team member and arrange it in a table. Okay, for nodal match superposition, source transformation, Thevenin or Norton, we have already correct the data at here. And for B, after discussion, we determine the correct value of load voltage, okay, which is this one, and we use mesh analysis as the final method to calculate the circuit. Okay, this is our manual calculation. Okay, so next, for part C, okay, part B, part C, okay, we need to calculate the phasor domain and time domain representation for the load current, voltage and current of inductor, voltage and current of capacitor. Next, for part D, we need to draw the phasor diagram and waveform for Z load, inductor, capacitor. Okay, of this we use the time domain function to calculate, to draw it. Okay, for voltage we use this one and current we use this one. Okay, next, for part E, we use the we calculate the maximum average power for maximum value of load Z max. So we apply Thevenin method at here, and then we calculate the Z max first, VTH, and also, and next we substitute all the value into the formula of PZ max, which is VTH square over 8 RTH. Then for the F part, okay, we need to calculate the real power and reactive power for voltage source 1, voltage source 2, line 1, line 2, and also the load. Okay, so for part B, simulation results and analysis. So according to the Malaysia standard, we set the supply frequency at 50 Hz. And for part B, this is our simulation of the circuit by using multi-sim. And later on, I will show Doctor our simulation by using multi-sim here. Okay, so next, this is the summary of voltage and current for the capacitor, inductor, and load. Okay, the last one is we also use the MATLAB to calculate the power of ZMax. This is our program or code, and this is the result here. Okay, this is our part of this part for discussion. So we've already compared the result from part A and part B. So we found that the result obtained in part A, which is the manual calculation, and the part B for simulation are almost same. So both can get the nearest answer, and those there's no any error. However, the multi-sim simulator can give more accurate result compared to the manual calculation. Okay, then for part A, I have already explained how I get the answer, and for part B, I also explained how the circuit to be developed by using multi-sim. Okay, then for conclusion, we have already I've already write down the theories, electric circuit theories that I have used and applied. Okay, like Ohm's law, Kirchhoff current law, and Kirchhoff voltage law. Okay, then at the end we also give a suggestion on this project. Okay, which is maybe we can add the dependent source such as dependent voltage source and dependent current source into the circuit to enhance the circuit. Okay, next, this our last part, which is the reference. Okay, we use 5 reference at here. Okay, next, I will show Doctor our simulation here. Okay, this is our simulation, the circuit. We have already used multi-sim to develop it, and the simulation is like this. Okay, so at first we use the voltage source for AC 1, voltage source 1 and voltage source 2. We set the value for voltage, frequency and also the angle. Then we arrange the capacitor here, inductor here and also resistor and capacitor. And don't forget we also need to put a ground here. Okay, then we also put the voltmeter and also the ammeter and ammeter. Okay, so when I stop it, okay, at here we can see that there is a VPP, is referred to V peak to peak, and IPP is referred to I peak to peak. So in order to get the result, we need to which is our result is only for peak value, which is VP and IP. So we need to divide VPP here, VPP, and IPP here by 2, divide by 2, so we can get the final answer. So I think that's all for our presentation. Okay, thank you, Arthur.